Today we're going to talk about solving systems of equations by graphing. First, some vocabulary. What do we mean when we talk about a system of equations? Well, a system of equations is a set of two or more equations containing two or more variables. If you look ahead at example 1, this right here is a system. It's not just one equation. In this case, we have two of them. That's what a system is. All right, so what do we mean when we're talking about solving a system? Right? When we're solving a system, we're looking for the solution. Right? And what a solution is, here's what it is. A solution of a linear system of equations is an ordered pair that satisfies each equation in the system. All right, and I'm using pair because most of the time we're going to be talking about having two variables. Right? When we have two variables, it's an ordered pair. And ordered pairs, if you remember, look like this, where we have an x value and then a y value. And graphically, what that looks like, that is a point. Right? That is a point in your graph. Right? The x value, comma, the y value. And that ordered pair has to satisfy each equation in the system. Right? What does that mean? Right? When we talk about it satisfying the equations, that means that if we were to take that x value and that y value and then substitute that into the equation, we would get a true statement. Right? So, and the key thing is that it doesn't just work for one of them. No, it satisfies each equation. Right? So if we were to take that x and y and substitute that into all of the equations in our system, they should all be true statements. That's what a solution is. All right, let's look at this first example. All right, we're going to find the solutions of this system. And we have these two equations, y equals negative 3x minus 1 and x minus 2y equals negative 12. And I've already gone ahead and graphed these. Okay, this line here, this is the line x minus 2y equals negative 12. And then this line is the line y is equal to negative 3x minus 1. Right? And we want to find the ordered pair that is a solution for this system. All right, so I want you to think about this by remembering what a line is. Right? A line is made up of a bunch of points, and each point is a solution to that line, that equation. Right? So for example, this point here is negative 6 comma 3, and that would be a solution to this equation, x minus 2y equals negative 12. This point right here, let's say we use this point. This is 2 comma negative 1, negative 2, negative 3, negative 4, negative 5. 2, negative 7. And this point here, 2, negative 7, would be a solution for this equation. Right? But what I'm looking for is a solution, an ordered pair that's going to be a solution for both equations. Right? And where is that going to be? Well, what point would work for both of them? That's going to be this point. Right? This is the intersection point. This point here, that is the point negative 2 comma positive 5. That's the only intersection point. That is the point that would satisfy both equations. Let me prove that to you. All right, so let's check our answer. All right, so let's check to see that negative 2 comma 5 will satisfy this equation. X minus 2y equals negative 12. So I'm going to replace x with negative 2, and I'm going to replace y with 5. And we get negative 2 minus 10 equals negative 12, which is negative 12 equals negative 12. That is true. Right? So negative 2 comma 5 worked in this equation. It satisfied that equation. Let's check the other one. The other equation was this, y equals negative 3x minus 1. And I'm going to replace y with a 5 and x with negative 2. Negative 3 times negative 2, this is 6. So 5 is equal to 6 minus 1. We get 5 equals 5, which is also true. Right? So this point right here, this would be an answer. Negative 2 comma 5. This point is the solution, the intersection point, because it satisfies both equations. When we replace it, the x and y with negative 2 comma 5, it would get true statements.